We all know there are 5 solid principles. But in this video, I will start with a question. Why solid? Why you want to use solid? Why? There are 5 core reasons, but if you are in a hurry, there is a one-line answer. Low change impact. And this is one of the main goals why you need solid. In really simple words, when you make a change, it should be controlled. You should not change a lot of places. Okay, before I dive into solid principles, let me quickly share 5 core reasons why you need solid. And the first is maintainability. Maintainability in software development is a measure how quickly and easily your application can be fixed or enhanced. So, maintainability is really important for long-term efficiency of a software application. And the key feature of maintainable softwares include clear, simple, and well-organized code, which makes it easier for any developer to understand and maintain the code in long run. And the second is code quality. Code quality in software development refers to the standard of your coding that ensure software is reliable, efficient, and easy to maintain. Follow best practices is also a part of code quality, such as proper naming conventions, consistent coding standards, and thoughtful architecture. Most importantly, developing sustainable bug-free softwares that effectively meets user needs is important. And the third is ease of testing. Testing does not mean test the code written by developers. It also means test the code to make sure it meets the user requirements. So the overall goal of testing is to make sure it's working as expected. And this is again one of the core reasons why you need solid. Modular component that can be tested independently, clear interface, and minimum dependencies. It allows for more straightforward and effective unit test and integration testing. This approach does not speed up the development. It also enhances the overall reliability and stability of the software. And the next is scalability. Scalability in software development refers to the ability of systems to handle the increased work. It is an essential aspect for applications that need to adapt to changing demand without compromising performance or requiring a complete redesign. Scalable softwares can accommodate more users and increase data. The quality ensures that the software can continue to operate effectively as the user base grows or need to process more data. And finally, reusability. Reusability in software development refers to creating code that can be used in multiple applications or part of an application without modification. This is important. Code reusability without modification. It means designing components that are general enough to be effectively reused in multiple contexts. It involves creating modular, well-documented code that follows standard design patterns, making these components easy to integrate, maintain, and use in various contexts or projects. And now you know the core reasons why you need solid. Let's dive into solid principles, and now it will make more sense. The essence solid is the single responsibility principle, SRP. The single responsibility principle says that a class should have only one reason to change. This means a class should have one job or one responsibility. Consider a scenario where we have a class that manages employees' details and also handles the printing of employees' reports. According to SRP, the class should be split because there are 2 reasons for its change: employee management and report generation. Here is the employee class is responsible for managing employees' properties, and the employee report class is responsible for printing employee report. And the idea is a class should have one job or responsibility to change. And if you have to make change, it's only at one place. And this is the overall goal, low change impact. So let's dive into the O of solid principles. The open close principle, or OCP for short. Imagine a bank that has been processing online transactions flawlessly for the past 50 years. Now suppose you are brought on board as a senior software developer to contribute to the existing software. How do you start writing code? A wise approach could be to think like, if it's been worked perfectly for 50 years, there's no need to change it. Instead, build on top of it. This approach is nothing but OCP. In simple words, OCP advises developers to craft their code in such a way that it introduces new features without changing the existing code. OCP points that software entities such as class, module, functions, etc. should be open for extension but closed for modification. It ensures that your software's core functionality remains stable, while still being flexible enough to evolve and adapt to new requirements. And next is Liskov principle. It is referred as Liskova substitution principle, or in short, LSP. Before I define it, let me share an example with you. Imagine you have a basic app that can play media files, and now you have written a class called media player, which has a function play and that can play any music file. Now you decide to upgrade your app to play video files. So you can create a new class called video player that extends media player. According to LSP, anyone using your app should be able to use the video player. This means if your original media player could play MP3 files, Your new video player should also be able to play MP3 files in addition to videos. A subclass should seamlessly fit into the places where a superclass is expected without any negative impact on the program's execution or behavior. Hope you get an idea about LSP. And now, let me define LSP in really simple words. The base class or the child class should be able to replace the parent class without any side effect. And the next is ISP. The interface segregation principle ISP is a key concept in object-oriented design that advises against designing large monolithic interfaces. Instead, ISP suggests splitting interfaces into smaller, more specific ones so that clients only need to know about the methods that are relevant to them. This principle helps prevent a situation where a client is forced to implement methods it doesn't use. So in essence, ISP is about client's freedom. If I have to define ISP, I will say, do not force clients to use methods which they do not want to use. The last, but certainly not least principle of Solid is Dependency Inversion Principle, DIP. The principle focuses on decoupling software modules, making systems easier to manage, adopt, and scale. And the essence of DIP would be high-level modules should not depend on low-level modules. Both should depend on abstraction. And abstraction should not depend upon details. Details should depend on abstraction. The dependency inversion principle is not same as dependency injection. Dependency injection is a technique that we can use to implement dependency inversion principle. And here is a bonus tip. There is something really important in backend development, writing clean code. It is more than just a skill. It's a bridge between technical proficiency and effective communication within the team. If you want to learn more about it, there is a video, 7 game-changing skills for 2024. And thanks for watching.